Okay, let us to start the lesson. Okay, page 209, example of energy conservation. The first example, simple pendulum, 鐘擺. Okay, when you look at this, okay, in the highest position and the lowest position, you should know that the PE, the potential energy, and also the kinetic energy, they are different. At the highest position, PE will be the maximum. At the same time, in the lowest position, KE will be maximum, PE will be minimum. But when you add them together, it means that the total energy, ME, total mechanical energy, they will be the same. For example, when you add PE and KE together to find out the total energy, inside this example will be 6 units. At the lowest position, everything will be converted into KE, 6 units. In this situation, PE will be 0. It tells us that total energy will be conserved, just only energy change from PE to KE, from PE to KE, from KE to PE, from KE to PE. Okay, this one will be the example of simple pendulum. And of course, when you look at your book, page 209, we also have the diagram to show that this one will be the height, x-axis will be the height, y-axis will be the energy. We want to find out the relationship between them. When you look at this H, this one should be related to the potential energy. The formula for the potential energy should be mgh. If H is 0, mgh will be 0. So here, H is 0, mgh will be 0, potential energy will be 0. But when it goes to the highest point, for example here, measure from this one, the reference line or reference point, this one will be H, then will be here. Then what is the relationship between it? Potential energy will be mgh. M is a constant, G is also a constant. So you can see that PE and H will be directly proportional. Finally, the relationship will be a straight line, like that. And also, we know that PE and KE, you can add them together to be total mechanical energy. So it means that this line should be total energies. I change the color. For the blue one, will be KE. Okay, when you look at this, H is 0, it means that the lowest position, KE will be maximum, but PE is 0. PE and KE add them together should be the total energy. It means that this one should be the maximum KE. At the same time, when PE is the maximum value, it means that here should be the highest position. KE will be 0. Okay, 0. Because PE is a straight line, a linear relationship, then KE will be the same, like that. Okay, you can draw this diagram. Energy against height, H. And also, we have the other diagram for the time. I draw here the time. And also the potential energy. What's the time? Depends on your initial position. For For example, I can let this one will be the initial position. PE will be maximum. Then if I say that like that, here PE will be maximum. KE will be minimum. This one is KE. But in a certain time, PE will be minimum, it means that 0, and KE will be maximum. But how about the relationship? Is it linear or a curve? It depends on the situation. I try to understand KE, the formula of KE. Yeah, KE. KE should be half mv squared. And also we can use we can use 4 equations. One of it will be this one. V is U plus AT. Then what happens will be like that. U plus AT overall square. Then you can find that when I explain it, you can find that this one, half AT square plus half and 2 cancel it, will be MUAT. The last one will be half MU square. Okay? Then what happened? You can see that T square, T, and this one. This one is the quadratic equation. So this one explains it. This part is not a straight line, should be a quadratic equation, a parabola. Okay, then what happened? I draw it here. Follow the point here. This one will be a quadratic equation, like that. At the same time, I change the color. Wet one. This one, add them together, will be the total energy. Then it means that I need to fit this curve downward, like that. Okay, you can see it, the result on your textbook page 209. The wet one will be watts. T is 0, but it will be the maximum. Okay, then this one may be PE, but of course, in other case, this one can be KE. But why? Try to look at this situation. Initially, I can start it from the highest point, release it. Then, in this case, PE will be maximum. It means that the wet line, this one, will be PE for situation 1. But actually, we have the second situation, maybe starting from the lowest position. At the lowest position, you can push it a little bit to make it move. Give it energy, KE, like that. Then at that time is 0. KE will be maximum. Then the wet line will be KE, like that. Okay? And that's all for this part.